Hi, I'm Ben Griffith, and today I'm going to be relating kinematics to parkour and free running, specifically laws of conservation of torque and how they'll apply to your rotations and flips. Basically, I'm going to talk about how fast you spin today and why you're not spinning fast, and why you land on your head in certain spots, and why you're messing up. In physics terms. I'm going to speak in really relative terms today. If there are any math or physics professors out there, or any engineers, I'm absolutely well aware that the units I'm using are not to scale and everything's kind of off. But I'm keeping everything relative so that the not engineering people that do parkour and free running, aka 99.5% of the player base there, can actually listen to me. So, torque is just force times distance. If I apply a 10 Newton force down on my hand right here, the torque relative to my shoulder will be 10 Newtons times half a meter. So 10 times 0.5 equals 5. That's my torque. And so we're going to look at different setups, different rotations, different things that people do during their flips that mess them up. Scenario 1 is the person is hunched over like this whenever they set up, rather than being straight. And so what this does, here we have force times distance equals torque. The distance is from the center of mass to the tip of your toe. So if you're scrunched over like this, whenever you set up, you have a low initial distance. A low initial distance leaves you with a low initial torque. So if you set up like this and then you tuck in, your distance, you tuck into 1, so you go from 1.5 to 1. The force that rotates you, rather your angular velocity, increases by 50% to keep the torque the same. From going 1 of the force times 1.5 the distance equals 1.5, you go 1.5 the force times 1 the distance. After you abridge a distance, your force increased by 50%, just in that way. So scenario 1, you got a 50% increase in rotation. That's all right. Good job. Could be better. Scenario 2, the person doesn't tuck fully. You know the people who go for a cheat gainer and kind of like flop in midair and then land on their head and they don't really drive over and tuck it in? This is for you guys. 1 times 2 equals 2. Let's say instead of starting out with 1.5, you're actually extended well. You're squaring up correctly. However, instead of tucking all the way into 1, as we did in scenario 1, you only tuck into 1.5. You don't fully tuck. Now, your force, rather how fast you're rotating, goes to 1.3 repeating, aka you only have a 33% increase in rotation. So there, in relative terms, you may want to consider tucking tight on all your flips. I'm talking about the cheat gainer specifically today. However, this applies to everything, whether you're rotating on a pivot or you're rotating fully around. This works on all axes for rotation. And now scenario 3. Let's say our distance is 2, so you're squared up correctly, and then you tuck in to 1. Meaning you tuck in, you decrease your distance all the way down to 1. Your force gets a 100% increase. If you square up and then you tuck all the way in, 100% increase in your rotation. Much better than scenario 2 and scenario 1. Torque has to stay the same the whole time in midair. So in scenario 1, whenever our distance is like this, we start out with a low initial torque, thus not giving us a lot of leniency with what we can do in increasing force during our rotation, or increasing how fast we rotate. Scenario 2, not fully tucking, is not taking full advantage of all that is in front of you. You have this opportunity with a very high initial torque, but you're not doing much with it, and you only get a 33.3% increase in rotation. Set up straight, and then tuck in tight. 100% increase. Double scenario 1, triple scenario 2. That's what you gotta do. Thank you. That is all.